In this tutorial, I'm going to show you how to build a one sample t interval for the sample mean, or to estimate the sample mean. And in order to do this, I'm going to look at the data we discussed in class that concerns the concentrations of the insecticide DDT in parts per million that kill at least 50% of a certain species of fish. So the data set that I have entered in the SPSS spreadsheet should look quite familiar if you have your class notes in front of you. Now our goal is to build a 98% two-sided confidence interval for this problem. So in order to do this, we go up here to Analyze, Compare Means, and then choose a one sample t-test. We choose our variable of interest here, which is the LC50 variable. And in order to make it a 98% confidence interval, we have to select options. And by default, it goes to a 95% confidence interval. But if we just type in 98% and click continue, then we're done. And that's all we have to do for this confidence interval. If we click OK, SPSS will pull up our results, which are relatively easy to interpret. The first thing in this set of results here is just some basic summary statistics. So what you'll see here is that you have the number of measurements of this lethal concentration. You have the mean lethal concentration that we've observed here. You have the sample standard deviation, so this is the sample mean, this is the sample standard deviation, and then we have the standard error of the mean, okay, which remember is going to be the standard deviation divided by the square root of this sample size. Moving on to the actual interesting part of the output results. It says a one sample test, but it also gives us a confidence interval, and that's really all we're interested in at this point. So it tells you how many degrees of freedom that you have in this problem. It's relatively easy to calculate. Remember, that's just your sample size minus 1. And then it gives you your desired confidence interval in the far right two boxes of the output. So here we find that the concentrations go from 3.96 to 14.04. And depending on how you rounded when you found this answer in class, it may be about right, or it may be just a couple hundredths of off. Now that is how we can obtain a confidence interval, but remember that we shouldn't be done here. We should also double check the assumptions that we've made in order to construct this small sample confidence interval. So what we need to do is check the assumption of normality and whether these observations could reasonably come from a normal distribution. So what you need to do is think back how we did that in SPSS and look at one of the previous tutorials to see how we could test normality.